Tall, slender stacks often use guy wires to provide lateral force resistance. Guy wire-supported stacks are much more complicated to design than freestanding stacks because the guy wires are non-linear in nature and because the guy wires resist any thermal expansion of the stack. Fortunately for MecaStack Pro versions and above, there is an option to allow you to add guy wires to your stack. Go to Geometry and then Guy Wires. First, there is some terminology that we need to discuss regarding guy wires. A set of guy wires is referencing all of the guy wires attaching to a given elevation on the stack. Each guy wire is attached to the stack at one end and then to a deadman at the other end. A deadman refers to an anchor point for the guy wire. Typically, this would be a concrete block at grade, but it could be elevated and attached to another structure. The guy wire is attached to the stack at the guy lug attachment. There is hardware that facilitates the attachment of the guy wire to the guy lug and also the deadman. First, you will select the number of guy wires per set. This is typically 3, but could be higher in some special situations. Next, we indicate where the deadmen are symmetrical. This selection will play a large role in the analysis that is performed. Ideally, all deadmen will be symmetrical, which means we can take advantage of symmetry and significantly reduce the complexity of the analysis. A symmetrical set of deadmen would be deadmen that all have the same angle between them, the same radius, and the same elevation. Since 3 sets of guy wires are the most common, we will use that for our discussion. When the deadmen are symmetrical, we can reduce the analysis to consider 3 different load direction: the 0-degree load, which bisects 2 of the cables, the 30-degree load, which acts along one of the guy wires, and 60 degrees, which is perpendicular to one of the guy wires. If the deadmen are not symmetrical, then things become more complex. When they are not symmetrical, we need to look at all of the load direction angles to ensure we capture the worst case. We select the angle increment that needs to be considered in the analysis settings screen when we perform the analysis. If we select 10-degree increments, since there are 360 degrees around the stack, we have to consider 36 different load directions for every load case. When we have symmetrical deadmen, we only consider 3 different load directions. When the deadmen are not symmetrical, we have increased our load combinations by 12 times. Next, we can change the guy wire settings by clicking the Settings button. These settings would typically not be changed, but can be if needed. Here you specify the acceptable clearances for hardware attaching to the guy lug. You can also control the safety factors that are used for the guy wire analysis. There is also the ability to specify how much extra cable is added to the guy wire lengths when wire rope clips are used, because this can vary for different companies' standard practices. The amount of guy wire weight considered to act at the guy lug elevation can be adjusted here. The default is to assume 100% is at the guy lug elevation. Now we move to the deadman entry. We need a minimum of 1 set of deadmen. Clicking the Edit button, we can specify all of the deadman dimensions and orientations. If you have symmetrical deadmen, then you only enter the parameters for the first deadman, and then all others are automatically generated. If they are not symmetrical, then you have complete control to enter all values manually. The Ultimate version has a feature that allows you to specify spring constants for the deadman rather than the default of treating them as rigid. This could be useful if you are anchoring the guy wire to something that is not rigid, such as an elevated column that might have some flexibility. The bottom section is where we specify the guy wires. Each row represents 1 guy wire set. First, the elevation for guy wire attachment is entered. This is the elevation for the guy lug hole. The next column is the pretension, where we can specify this as a force value or as a percentage of the cable breaking strength. A value of 6% of breaking strength is typical, and you can refer to the help and articles on our website for more discussion on pretension. Next, you specify the type of cable being used for the guy wires. There are many different options in the database which can be selected. The selection is a complicated decision. Generally, it is recommended to use wire rope because it has more flexibility to adjust the length in the field by using wire rope clips on one end, and it is more flexible and is less severe when the stack experiences thermal expansion. There are times when more strength and stiffness is needed, and then structural bridge strand would be used, but it does come at a price because wire rope clips cannot be used on structural strand, and it puts more stress on the stack when thermal expansion of the stack is experienced. Next, we specify how the guy wire is attached to the stack guy lug. Typically, an open spelter socket is used. Please note that beneath each option there is a percentage displayed that represents the connection efficiency. A 100% value is most desirable. A smaller value can cause the guy wire to increase in diameter. If the type of hardware being used is not displayed, then select Custom and manually specify the connection efficiency. Next, we enter the guy lug details by clicking that button. Please refer to another video that covers the guy lug entries. Now we move to the deadman column where we specify which set the guy wire set is attached to. If there is only one deadman set, then there will only be one selection. Finally, we specify how the guy wire is attached to the deadman. The options displayed represent the most common hardware options. Typically, a turnbuckle or take-up are used because these are adjustable, allowing for construction variances in dimensions, as well as giving a way for the pretension to be placed on the cable. The type of cable selected will dictate which options are visible. For example, structural bridge strand is very stiff, and you cannot bend it to install wire rope clips. Therefore, the wire rope clip option will not be visible. When the load on the cable becomes very large, then there may not be a turnbuckle capacity high enough to handle the load. In this case, you can use a take-up, which has much higher capacities. The take-up also has an advantage in that it can be purchased with a large amount of adjustment. At the bottom of the window is a Print Guy hardware button. This produces a one-page summary of each guy wire set and sends it to a printer. The printer could be a PDF printer if you have one selected. It doesn't convey everything, but it does summarize most of the important guy wire information. When we save the guy wire entries, we then see the graphical representation of our selections. The graphics do not show the hardware, but the guy wires and guy lug attachment are represented graphically.